Here I'll show you a quick trick to select U and DV a little bit quicker than trying both approaches, right? So you can always try one approach, and then if it doesn't work, you can reverse U and DV. But there's a shortcut, and there are a variety of acronyms here that people use to apply this shortcut. And this isn't a magic rule, it's just a trend that tends to work. So I'll illustrate with the example we just did, where we had the integral of x times the sine of x. And if you separate these two functions, we have x and we have sine of x. X is a polynomial and sine of x is a trig function. So what we do is we arrange these types of functions into a scale using the acronym LIPTE. Now, before I go on, I should mention some people use things like LIPTE or other arrangements, and there's a little bit of a turf war on those, but LIPTE works. The other ones also work, but this is the one that I like to use. So that stands for logarithmic functions, inverse trig functions. I say polynomial-like, and the reason for that is it's things like x, x squared, x cubed, etc., but also things like the square root of x, which isn't technically a polynomial, but x to a power, basically. So you could think of like power functions, but that general category of polynomial-like things. And then T stands for trigonometric and E for exponential. So in our case, we've picked out x fits here and sine of x fits here. That's our setup. And the trend is whichever one is higher on the list, you're going to select as U, and whichever one is lower on the list, you'll select as DV. Now the reason for that kind of goes back to what we observed in that problem, where the sine function, or trig functions in general, tend to kind of cycle through trig functions. So if you're doing something like finding du or finding v, whether you're differentiating or integrating, it tends to kind of cycle through those trig functions. The bottom of the scale, the exponential function, is the ultimate case of that, where e to the x will just cycle through and stay e to the x forever. So those things that exhibit that kind of cycling case tend to be more useful as dv, and the other ones tend to simplify when you take their derivatives, and so they make more sense to use as u. That's kind of a rough sense of why this works. Again, there's no deep mathematical truth hiding here. It's just a trend that has proven to be useful, and if you apply this scale, it can save you a little bit of time in selecting u versus dv. So that's how we knew in the last example to make u equal to x and dv equal to sine of x dx from the very beginning, without having to try one approach and then, if it fails, trying the other. So this is a good shortcut to use if you're starting a problem and you want to select u versus dv. Just remember LIPTE.